welcome back to my YouTube channel. In this video I am going to discuss about cyclotron. Okay, so cyclotron is a machine. It is normally used in the nuclear reactor and for radiation therapy. For that this machine is to be used. What this machine will do? This machine will accelerate the charged particle and ions. Okay, so what is this machine will do? Machine will be accelerate the charged particle. Okay, accelerate the charged particle. This is the construction of the cyclotron. It consists of two hollow metallic D-shaped containers. These are all the two hollow metallic D-shaped containers. These two containers we will call it as Ds, D1 and D2. Okay, these Ds is to be connected to an oscillator to provide an electric field between the plate, between the Ds of. So I am considering here it is a positive and negative charge. Okay, so it will produce an electric field like this. To provide the electric field in between the Ds, there is an oscillator is to be connected. Okay, and the magnetic field is acting perpendicular. Okay, then there is a deflector is there. Through why this deflector is connected? To get a charged particle, the accelerator charged particle, to get out from the Ds, there is a deflector plate is to be connected. Okay, and this entire setup is to be placed inside a chamber. Okay, then this is the construction of the Ds, this cyclotron. Okay, so actually the cyclotron is to be, the Ds are to be like this. You can see that it is to be like this. Okay, the field lines are acting like this. Okay, the field lines are acting like this. Okay, then so what is the working principle? This is the working principle. Frequency of revolution of the charged particle in a magnetic field is independent of the energy. Okay, this is the working principle. Now we will see the working. What is the working of the cyclotron? Okay, so if I am assuming that I am going to place a proton here. Okay, I am place a proton here, and the charge of the proton I am going to consider it as Q. Okay. So what will be happen? This proton is to be repelled by this positive plate, so it will be comes towards this. Okay, comes towards this. While coming into the D, there is a magnetic field is there that is acting perpendicular to this charged particle. So we already studied, if a magnetic field is acting perpendicular to the charged particle velocity, it will move in a circular path. You can find out the direction by using Fleming's left hand rule. Okay, you can see this. Okay, it is to be coming out and the charged particle is to be enter here. Okay, coming out and the charged particle is enters. Okay, by using Fleming's left hand rule. Okay, then you will get this. What will be happen? You will get this. This force is to be acting, so it will move in a circular path. Okay, it will move a circular path. Clear? It is moving in a circular path. Then what will be happen? If it will be reaches to here, If it will be reaches to here, what is acting here? Here there is an electric field. If it will be reaches to here, the sign of this electric field will be changes. This all become positive. This side become positive. This whole side become negative. So this positive plate is repelled by this proton, so it will be try to come out like this. Okay, when it is at the electric field, what will be happen? It will experience a electrostatic force. How much is electrostatic force? That is F is equal to QE. Okay, clear? In between that is. In between that is. Okay, this force is equal to MA. So what you can equate it? So what you will get? QE is equal to MA you will get. So from this what you can write it as A is equal to QE by M. That means what happened? When the electric field is in between the D's, it will experience an acceleration, that is this. So if I will assume the initial velocity is to be something, so if I am going to assume the initial velocity is V, after some time this V will be increases. So when a charged particle is to be passing into it, it will increase. So V is equal to what? V dash. Now V dash is equal to V plus 8. What is 8? Is the acceleration, and what is T? How much time it is to be there in between the D's. Okay, so we will get the velocity. Clear? Okay, so here coming to here it is become to be accelerate. Okay, in between the accelerator, and it is to be now reaches to the magnetic field. There it is acting perpendicular. So the particle is to be moves in a circular path. Like this it will moves. Okay, but you see now here the radius will be increased. Why? You see the formula. When a charged particle is moves in a magnetic field, that is QVB. Here sin theta is equal to what you will get? QVB sin 90, that is equal to QVB. Due to this force, the charged particle moves in a circular path. If anything moves in a circular path, it needed a centripetal force, that is mv square divided by r. So VV cancels. So what you will get? V is equal to QBR divided by M. This is the velocity of the charged particle moving in a perpendicular magnetic field. So that means what? Velocity is directly proportional to radius. You see here the velocity is V. Okay, after reaching here, if the velocity is increased to V dash, that means velocity is increases. What about the radius? The radius also increases. Clear? Okay, that is the thing. Okay, when again it will becomes here, the electric field will be changes. Okay, then. So that the cyclotron make this charged particle to move in a circular path inside the disk. Okay. So what is the time period? Time period means time taken to complete one revolution. Time period of the cyclotron, that is equal to 2 pi m divided by qb. Then what is to be the frequency? That is frequency is equal to 1 by time period. So frequency is equal to what you get? QB divided by 2 pi m. QB divided by 2 pi m. This is the frequency of the charged particle moving in the disk. This is the cyclotron frequency. Cyclotron frequency. Okay, so you see here in the cyclotron frequency that is QB by 2 pi. This is B. B is the magnetic field M is the mass of the charged particle, Q is the charge. It is not to be dependent upon the velocity. So it is not to be dependent upon the kinetic energy. Whatever the time the charged particle to be revolved, it is independent of the velocity or to be the energy. That is the working principle we already studied. Okay. Then to work it is properly, this electric field direction has to change alternatively. Whenever this charged particle complete half revolution, the sign of the electric field has to change it. For that, we have to be connected to an oscillator or an alternating voltage source. What about that frequency? That applied voltage frequency should be equal to the frequency of the cyclotron. Then only when the cyclotron will finish half revolution, the sign will be changes alternatively. Okay. So, what is the condition for a proper working? Applied voltage. Applied voltage frequency, that is mu A is equal to the cyclotron frequency. This is the condition. Okay. So this charged particle will be continuous revolution each time it is crossing between the D's. It is to be accelerated. Okay. And when it is accelerated, the radius will be changes. Okay. Okay. This is where thing is to be happening. What is meant by the deflector plate? If it is to be a positive charge, there will be a negative plate. So it will be attracted towards, and the charged particle is to be coming out from this, through this, the charged particle will be comes out. Okay. The charged particle will be comes out. Okay. That is the exit port. Okay. Then, what is the velocity of the charged particle coming out from the exit port? We have to see. Okay. Velocity of the charged particle is V is equal to this formula in this QB divided by R, QBR divided by M. What is R? Capital R is the radius of the D's. Radius of the D's. Okay, clear? And we will see what is its kinetic energy. Kinetic energy formula is what? Kinetic energy is equal to half mv square. That is equal to how much you will get? So you will get here, that is half into m into v square, that is q square b square r square divided by m square. This m and m is cancelled, so we will get the kinetic energy of the charged particle coming out from the cyclotron is q square b square r square divided by 2m. Okay, this is the kinetic energy, and this is the velocity of the charged particle coming out from the cyclotron. What is R? R is the radius of the D's, and B is the magnetic field, Q is to be the charge, and M is the mass of the charged particle. Okay, and this cyclotron is to be using in radiation therapy in hospitals. We have to be using for the treatment, and for scientific researches we have to be using, and nuclear reactors we have to be using this cyclotron as a charge accelerator.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.